Sorry for the delay, folks. So, I have a very special treat for everybody today. Slides. I'm, some of you may be aware that I'm kind of working on like a rewrite of the course at the same time that I'm teaching the course. Unfortunately, I don't have time to like keep up with it. But occasionally, yeah, there's like overlap, and like if I have slides for you on the topic I'm about to teach, I'm going to use those, obviously, right? So, especially if they're my slides. Oh man. So yeah, that's what we're going to do today, because we're going to talk about functions in JavaScript. Functions in JavaScript. Huzzah! We didn't do functions already, did we? I don't think we did. All right. Good. So, let's see here. So the slides are kind of in a slightly half-finished state, but they'll be good for as long as they last. Why aren't my arrow keys working? Oh, you want me to use page up and page down, eh? No? Might have to use a different viewer then. One moment, please. Oh yeah, it's default document viewer. How useful is that? Not very. All right. Let's see here. There we go. Let's see here. View mode. Single page, yes. View would be what I'm looking for. There we go. Full screen mode. That'll do. Look at those beautiful little slides. Oh, you're just going to see the world for the first time, slides. Oh. Okay, so we're going to talk about functions in JavaScript. So, a surprisingly deep topic, functions in JavaScript. It turns out that our intro Python course level understanding of functions is not going to be sufficient to get us through JavaScript. We have to know a few more things. Incidentally, if there are any spelling mistakes, I apologize, but the slides are actually literally not finished, so there you go, that's okay. They're still, in my view, superior to what we had before. So, all right, functional programming. Oh, we did you're doing job with me, right? Yeah. We talked about overloading, like, last week in Java, just a little bit, so, so, these two topics aren't done, so we're not going to do them. Well, we'll do them, but not, like, here. So, ta-da! Function overloading. So, I really like this quote. I believe C++ instills fear in programmers, fear that the interaction of some details causes unpredictable results. Its unmanageable complexity has spawned more fear-preventing tools than any other language, but the solution should have been to create and use a language that does not overload the whole human brain with irrelevant details. I feel like that's also applicable to JavaScript. So, functions. Functions, functions, functions. Everybody should know functions from Python, right? What do we use functions for, anybody? What's a function for? Yeah. A command?
Like a command or a separate, like a subsection of the code.
Subsection of the code is toward what I'm driving at, yes. So,
For like, to specifically to activate at a specific time, like, so it could like do its function specifically and it's different from the normal base code.
yes. Yes? Yes. So we want to take a procedure, right, make a function out of it, so we don't have to rewrite that code every time we use it. If there's one thing that programmers hate, it's saying the same thing twice, right? So, if there's one thing programmers hate, it's saying the same thing twice. Ha ha ha, that was a joke. All right. So, there's a very good reason for that. If you're duplicating code, you're also duplicating all of the bugs in the code. And if you ever have to go fix a bug, you would prefer to have to only do that in one place as opposed to 20 or 30 places, right? So, all right. So, from a historical perspective, we used to call these subroutines. So if you think of a set containing functions, methods, and yes, even programs themselves, these can all be loosely categorized as subroutines. So, behold, the function. This is the basic function syntax for a function in JavaScript. You'll notice the syntax is broadly similar to Python. Python, not Java, right? The most, the biggest difference between the function declaration here in JavaScript versus in Python is the exchanging of the def keyword for the keyword function, which honestly is a bit more apropos. That is actually what the thing is. When you declare a function in Python, you're not declaring a def, right? Although def is short for define. So, note, we're still using curly braces and semicolons as per usual, but unlike Java, we do not provide a return type for the function, nor do we provide types for any of the parameters. Recall that JavaScript is a dynamically typed language, so we can't constrain our functions to have particular typed arguments. We cannot constrain the function to have particularly typed outputs, right? Like in every other language, defining functions does not call the function. This must be done separately, for example, as so. But of course, this should not be any surprise to anybody. Any questions so far? All right. Next slide, please. There we go. Because JavaScript is a dynamically typed language, the return type of a function cannot be known ahead of time. It must be determined at runtime, and the only way that we know what the return type of the function is that we infer that type from the actually passed return value. So, this means that we can't really have truly void functions, right? You remember void functions from Java, right? What's a void function return? Or are you all avoiding the issue? What's a void function return? Yes.
Nothing.
Nothing. Nothing. Nada. Zip. That's right.
You're returning nothing specifically.
Yes. Well, no. Actually, you're returning nothing at all. Like there is no return value, right? This is
Yeah.
this.
Basically what it is, like you're returning.
Right. But here's the difference, though, right? There's a difference between not returning anything and returning a literal of a void type, right? In Java, in JavaScript, pardon me, whenever we return nothing, quote unquote, from a function, we're not actually returning no literal value. We don't know what the return type is without a value to do type inference on, right? So, when functions in JavaScript fail to return anything, either return is used without a return value, or the function simply lacks a return statement, period. The function returns undefined. Now, we all remember undefined, right? What's undefined? I'm asking you for a definition of undefined.
Define, like there's no definition.
Well,
Like in math, right? It's like when you don't have a solution.
yeah, a little bit like that. Although, as we'll see, in instances where regular mathematics would have undefined, we actually are more likely to have not a number or null or even the infinity literal. Undefined, the best way to describe it is that it is a void literal, right? So it is the only, well, it is one of only a small set of values that a void thing can have, right? So in JavaScript, undefined is normally used for primitives, and null is usually used for objects. You guys know the difference? You know what a primitive is, right? Anybody list me primitive data types?
Like primary data type? Is it like that?
What? Tell me what you think a primary data type is, and I'll tell you the answer.
I think a primary data type is an active type of data that the code is led by and is the structure of what the code is led by.
Yeah, but like if you were to actually tell me what data types are sets of the set of primitive or primary data types, what would they be?
Oh.
Anybody else
It's
care?
been a hot minute.
Yeah. Anybody else care to take a stab at that one? Silence, phone. Integers, booleans,
Right.
floating point numbers,
String.
strings. Well, actually, it depends on your language. If you're in a C, if you're in C, then strings are actually character arrays. Arrays are a primitive data type, so strings are a primitive data type in C. However, in both Java, JavaScript, and Python, C, the string is actually an object type. So actually, no. So there we go. So I would like you, everybody in the room, please open up a browser. We're going to actually do some code.
Google or in code editing software?
It makes actually no difference. We only need the we literally only need a web page. All we want is the JavaScript console. So yeah. There we go. Nice pretty background. Inspect. There we go. Console. console, there we go. All right. So let's write a function that doesn't return anything. I want to share. This is a part where please repeat after me. Function hello console.log Jello there we go. Now we get an undefined value here as well, right? But please understand we have not called the function yet, we've merely defined it. JavaScript is a language in which pretty much everything has a return type. Even defining a function has a return value, and that return value is undefined. So, let's execute the function. Hello?
Sir, how did you get that? Keep trying to do it, but it doesn't work. Function thing.
So, you're in the console?
Yeah, I'm in the console right now.
Are you holding shift while pressing enter to get the next line?
Hold up, I think I got it.
You got it? Okay. Everybody else get that? Very good, very good, very good. All right. So, if you'll note, when we execute the function, we get Jello as the output, plus, if you look at the little back arrow thing, I thought I told you to be quiet. If you take a look at the little back arrow thing, that is the evaluated value of the expression. That's the return value of the expression. So we can see undefined is, in fact, what the function returns if it doesn't return anything. Yes?
How'd you run it?
You type the name of the function, open and close brace, press enter.
Okay. So yeah, just type the name of the function, let's run.
Yeah. This code is a joke, by the way. A function to annoy mom. It's my turn to play with that. No, it's my turn. Loop 100 times. So, all right. So the return type, if you don't return anything, is undefined. All right? So, let's now consider what happens when you don't provide enough parameters to a function. So, in Java, you would not be allowed to do this, right? In Java, if you do not call a function with the required number of parameters, that is strongly a syntax error. However, in JavaScript, it's, this is a very loosey-goosey, come-as-you-are kind of language. And so, if we have a function which we define, let's say add 3, x, y, and z, let's evaluate this and see what we get, everybody. So please, return to your console and enter those values along with me.
Rocket?
Okay?
Rocket
Okay. Everything inside of the code blocks. These, oh yeah. So that's not a character you type, that's meant to look like the little console prompt, right? Sorry, I'm not using those consistently. See, that's one of the things I was saying about this being like the first draft. So, all right, so let's write a function. Function, add 3 x, y, and z. Return x plus y plus z. There we go. Add 3.
So you said
1, 2, 3. Yes.
So you said hold down shift and then what?
Shift and enter gets you to the next line.
All right, got it.
Yeah. Yeah, doing multi-line inputs into the command prompt is a useful thing to know how to do. Another useful thing to know how to do is using back arrow to access previously entered commands. You can use the arrow keys to scroll through your command history. So far so good. That is the expected result, no?
I got it.
Awesome. All right, now let's see what happens. Just as an experiment, what happens if we get, uh-oh. Not a number. Well. That seems like not the one that we wanted, eh? Eh, boys and girls, eh?
I know why.
You know why?
It's because you only put 2 values, right?
It is, yes. So, it is because we only put in 2 values. So, does anybody care to guess what's happening to cause this, though?
Function itself. What I mean is, it was made to take 3 values and not 2.
Yes.
So if it's taking only 2 values and it's not the third one, it can't properly run.
It can't properly run. It's true. Yes?
Is it because it's adding a null value?
Very close. Very close, yes.
I think JavaScript is still loading the function even though it's missing a parameter and you're just getting a not a number, whereas in Java it will just stop completely and give you an error.
Yeah, you were closer. So it's not a null value that it's throwing in there, but it's an undefined value that it's throwing in there. Let me show you. Okay, listen, phone. I hate you. I wish you would blow up. I wouldn't have a phone anymore. That would be great.
That's a really good idea. Lithium-ion battery explosion is a really good thing.
It solves all your problems, really. Just don't do it on a plane or you might kill people. Where's my cursor? There's my cursor. So, this is how the function gets evaluated. Surprisingly, we get not a number. We have add 3, 1, and 2. This evaluates 2, x plus y plus z, same as it did before, but note, with x is 1, y is 2, and z is undefined, right? So, the rule is, if you undersupply arguments, it's not like it doesn't go ahead and run the function. It substitutes in undefined for any parameters that you failed to define. Okay, on the surface that makes some sense, but let's dig into the implications, shall we? So, we substitute each of these variable values into the expression. We get 1 plus 2 plus undefined. We evaluate one further step. 1 plus 2 is 3. Anybody disagree? No? Okay, good. 3 plus undefined. What we are doing here is arithmetic addition on a number and a thing that's not a number. The result of that in JavaScript is not a number. which is another form of error literal, right? So that is where the not a number comes from. Make sense? You guys follow that that line of execution? Thumbs up? Awesome. So, so yes.
I have a question actually.
Please.
If you're adding 3 to undefined, shouldn't you just get undefined anyway instead of not enough?
Well, I mean, you might think that, but if we pull in the browser, right? 3 plus undefined is just not a number.
Oh.
Because it's a different form of like error literal. Technically, like undefined isn't an error literal, right? Like an error has not occurred until we try to add 3 with something that you can't add to things, right? And that's the condition under which JavaScript will insert not a number.
Oh.
Yeah, one of the conditions. It's just, you know, because this is JavaScript, I kind of have to tell you, you know, how it behaves without like, you know, there is some design ethic behind it. It won't match yours because it's a crazy language.
Is there any use cases to this where it's actually useful to have it this way?
Not really.
Oh.
No.
Oh. Okay.
Of course, that I'm gonna say that though because like I'm biased towards statically typed languages that don't behave like this, right? Alt tab, Control tab. What's the tab thing? Shift tab? No.
Just switch on.
I was looking for the shortcut to bring my slides back up. That's okay. All right. So, yes. This has often undesirable consequences and should be avoided if possible. Right? Like, we had a calculation that worked and then it broke. This is bad. Right? It's especially bad in JavaScript because JavaScript will just carry that not a number through all the way forward to where it will be seen by the end user. And if there's one thing we don't want the end user seeing, it's stuff like not a number, null, undefined, etc. Right? Good. Do you guys like the slides, by the way? I'm fishing for compliments right now. Okay, so let's say you wanted to fix that. You wanted to check for unknown, for undefined values, right? Well, it could look something like this, right? If you notice, like this is kind of the compact syntax that doesn't have the curly braces, which I occasionally use to make things fit on a slide, right? But yeah, first we check Z to see if Z is undefined. If it is, return X plus Y. If Y is undefined, return just X. Y being undefined presumes that X is also undefined. If X is also undefined, then all 3 are undefined, return 0. In all other cases, return the sum of all 3. Now, I don't know about you, that looks like a bit of a mess to me, right? Do you want to have to do all of this work every single time you write any function in JavaScript? Probably not, right? Also, please, 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 recognize that, unfortunately, with this font, this ends up just looking like one really long equals sign, but that's actually 3 equals signs characters. I'm going to have to find a different character. Okay. Strong equality is mandatory in this situation, right? This is a, undefined is one of those null-ish, zero-ish values. So if we want to distinguish between an actual zero and undefined, we need to use strong equality in this situation. Does this make sense? Any questions? So, I want everybody to say it. There's got to be a better way. Boop. There is a better way.
Return it.
No. Optional parameters. So, JavaScript gives a slightly more elegant mechanism for solving this problem than loading up every single function with a whole bunch of if statements right underneath the header. And that is the optional parameter. By the way, you can also do this in Python. You're going to learn quite a lot about how Python works by learning JavaScript. So, note the difference here. We appear to be performing assignment inside of the function header. 0, 0, and 0 being assigned in each case. So this is what this is doing, all right? This is setting a default value, right? If the argument is undersupplied, then this function will now use the default value, which we have given it, rather than undefined. Make sense? Now, in this particular case, this is a somewhat simple example, right? We have a good identity value given to us by the definition of arithmetic addition, right? We have a value that does nothing when added to something else. It is 0, right? That's called an identity value. Other situations you won't be so lucky. But, if you're in the situation where you have it available, you should use it. Make sense? So, let's try that out, shall we? Everybody get your console back up and running. So, you can just scroll back to where we defined add. There we go. If we put in equals 0, equals 0, and equals 0, there we go. We've redefined the function. And now, calling it with 1, 2, 3, you get 6. Calling it with 1 and 2, you get 3. Which is, of course, what we want, right? Pretty good. Any questions? Marvelous. Hopefully there are no questions because everything is clear. And not because I've just completely blown everybody's mind. So,
Sir?
Yeah.
Still getting
still getting nan? Let me take a look for a hot second. Let me see here. Yes. It's saying
Oh, wait, I see.
syntax error.
Yeah, I just forgot a comma.
Well, actually, no, the problem is you're creating a function, not a
Oh,
function.
That too.
Yeah. Spelling is a harsh mistress, particularly in programming code. Congratulations. Every single one of you have selected a discipline where a single character out of place means the whole thing doesn't work. If I had like little party poppers, I'd pop them for you right now. I should keep some in my briefcase. That'd be awesome. Yeah. You guys know Simon Galton?
Nope.
Simon Golden.
Yeah. You might have had him for intro networking.
He made, I remember, I think he like created the whole grid game, right?
Well, he created intro networking at least. He's a professor on the networking stream. Yeah, he owns quite a few courses.
I had a Brandon.
Let me tell you one of his stories about misplaced numbers. Okay. So, before he worked here, our friend Simon worked in the nuclear industry, right? And in the nuclear industry, it's quite common to have code that's been around for a very long time, like code that was written in the 60s and 70s, right? That it's like, oh, this performs very important calculations. We need to keep this code going, right? But of course, all code must eventually be forward ported to a new computer, right? So this was what was happening. An engineer had a program that was written for an older computer that needed to be forward ported to a new one, and is like, doesn't compile on the new computer, I'm keeping the old computer. So Simon's like, I'm going to literally drive to Ottawa and debug your program for you. So he did. 6-hour drive, you know, he's like, he gets off the phone with the guy, because you know this was before email, I presume. He gets off the phone with the guy, and 6 hours later he arrives in Ottawa, much to that guy's dismay. So, they use a very clever technique to, he uses a clever technique to isolate where in the program the bug is occurring. Basically, he takes the program, comments out half of it, see if it compiles, right? Don't worry about the functionality, just see if you can get past syntax checking, right? Oh, okay. The bug exists in the part we didn't comment out. Okay, we'll divide that again. So you can keep dividing the thing in half until you eventually arrive at the portion of the program where the bug has to be. You want to know what the bug was? I will show you. Very difficult to spot. That was a comma, not a period. So first of all, how was it that wasn't a syntax error before? Well, in the particular version of Fortran that this program was originally written in, you guys know Fortran? Definitely not 4chan. Fortran. Fortran is a very, very old programming language. It started out on punch cards. Fortran stands for Formula Translator. It was one of the first really big programming languages. But in original Fortran, this comma just meant that the rest of this number was ignored on this line. So it's like, oh, this very, very important code that is very important for nuclear applications, was it approximating pi as 3 all this time? And it turns out no. For some reason they defined this constant and then just never used it. They used the definition of pi in the math library, which is definitely what you should do, right? So it turns out they didn't actually ever use this anywhere, but a period for a comma, pretty difficult to spot, right? So 1 character, your programs must be correct to 0 characters of error. All right, this is the task before you. All right. So, all right. So, all right. So let's consider this one now. Let's take our add example. Let's run this now instead. What do you think is going to happen?
I think it's going to be 1, and then 1 and 5.
1, 5 is the output you're expecting?
Yeah.
All right, that's reasonable. Let's take a look, shall we?
In quotation.
As a string, yeah. Add 3. 1, 2, 3. So, you were right mostly, but you just you got mixed up right associativity versus left associativity, right? So, because it's x plus y plus z with no brackets, it will evaluate the leftmost expression first, right? So 1 plus 2, that's concatenation. The result is the string 12, etc. Make sense?
Yeah, I remember you saying
But this is still undesirable output, shall we say, right? So, for one thing, the function is no longer doing what it says it does. This is not addition, right? So the function's functionality is disagreeing with its own name. This is probably a bad idea, right? So, this may seem like a bit of a silly, contrived example, but as a matter of fact, this type of thing occurs frequently in JavaScript. This is a common error. Why? When we get to studying page manipulation, which we're going to be doing next after we get through functions, you'll see that element properties are stored as string data in the document object, even if the data is numeric. So when you're modifying the HTML file of a file, even if the attribute you're trying to modify is a number, and just a number, it's still stored as a string, which means that if you try to add a number to it, 1 plus 1 will equal 11. Make sense? This is the type of thing you actually have to be on top of in this thrice accursed language. So, how do we fix this? Well, the horrible and sad truth is, a lot of the time we don't. Right? A lot of the time JavaScript developers will not worry about this particular problem, despite the fact that it's a problem. It'll be something like, oh, just use the function correctly and you'll be fine. Right? JavaScript does not support type annotations. Unlike Java, there's no way to constrain a function to have particular input types on its parameters. You can't do it. It's a dynamic language, right? If this seems like the sort of thing that you should use, that should be useful, I would draw your attention to another language that's far superior that has this ability. TypeScript. If you want well-typed functions in JavaScript, you should be using TypeScript. Perhaps everybody should be using TypeScript. Perhaps I should be rewriting this class to teach TypeScript instead of vanilla JavaScript. I mean, yes, but like, you know, baby steps, right? Good grief, you know the course as it sits in the shell, like, kind of just doesn't have the last 15 years of updates to JavaScript as a language, you know? This is why it's important to buy textbooks. So, JavaScript does provide a way to tell what the types of things are. This is the type of operator, which, by the way, is an operator and not a function. The difference being, operators you do not require round braces, functions you require round braces, right? The type of operator can be used to check the types of incoming parameters. So we end up right back in our ugly mess of code with one if statement for each of our incoming parameters. If type of z is not number, z is equal to 0, which is basically not even doing type conversion, right? Because that's kind of presuming it's a string. So this would handle, like, if x were, you know, a string or a boolean or a, you know, one of those nullish values as well, right? It just, if it's not a number, it just zeroes it out, right? Which, you know, maybe you want something more specific than that, but at least this behaves in a stable way now, right? We've fixed the problem where it'll output a string randomly if you give it a string input, right? But yeah, type of, x, y, z, or z, y, x, number, there you go, right? Does this make sense? Any questions? At the cost of considerable code ugliness. So, when people speak about writing clean code, this is not clean code, all right? This is ugly code, but ugly and functional. Any questions? All right. So, all right. One more thing we need to talk about. Oversupplying parameters. So we've seen what happens if we provide too few parameters to a function. Now let's see what happens when we provide too many. Shall we? So, once again, please open up your consoles and try the following. Add 3. 1, 2, 3, 4. Well, so what do we get? 6, that's right. What is the actual sum of all of these? 10. But, you know, so we're not, like, it's not an error necessarily, right? But it's like, we're still losing information, right? We're providing a value that's kind of getting thrown into the bin, right? Again, this is not something that Java would allow you to do. You couldn't get away with this in Java, right? So, all right. Should have brought a mouse. So, here's JavaScript again for you. So, it's not that any extra arguments are lost completely. You can actually retrieve them. Every function has an arguments keyword, an arguments array, which it automatically populates with all of the arguments which are provided to the function. So basically what it's doing is it's taking all of the arguments that you give it and it plops it all down in an array, and that array can be used inside of the function. It's only defined inside of the function as well. So, by the way, do you guys know the difference between an argument and a parameter? Because these are often used as synonyms, but there's actually a technical difference between a parameter and an argument.
Parameter is more making sure that goes zero to kernel. Argument is just, well, part of the code that needs to run.
I'm sorry, sir, that's incorrect. Anybody else care to hazard a guess? So it's the difference between the variable and the value of the variable. All right? So during a function declaration, these are the parameters. X, Y, and Z are the parameters. When we call the function and supply 1, 2, 3, and 4, these are the arguments. So the arguments get mapped to the parameters and then the function executes. So there is that's the difference.
So,
Make sense?
So basically it's like the arguments are like what the parameter is equal to?
Yeah, during runtime. Yeah, they're the value stored in the parameter.
So yeah, it's just literally what each value would equal.
Yes. And now that you know, you will never be able to unknow that. Haha. Anytime you're in a room with other programmers, and somebody uses the word argument and means parameter, you'll say, ha 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 ho, I think you meant parameter. And they will be like, you're being unnecessarily pedantic. And you will say, yes. So let's try that out, shall we? So pulling on our definition of add, we can, if we wish to accept a fourth parameter, plus arguments. Arguments is an array. Arrays use 0 indexing. There we go. Now, you will see, if we enter 1, 2, 3, and 4, we get the value 10. Hooray! All right. Looking good, looking good. But what if I want a fifth? What if I want a sixth? What if I want a 22nd? Well, the programmer in you should be saying, if you want to enter 22 arguments into a function, you should probably be entering an array. Right? But let's just go with it for now. So, if you're going to do something like that, you know, you could actually just rephrase our earlier iteration to arguments 0, 1, 2, 3, right? Of course, this generalizes quite well. Just loop over the arguments, right? Let sum equal 0. I is less than arguments dot length. Sum plus equals arguments return sum, right? Very, very typical and standard summing loop, right? Make sense? What are we not using here, though? What are we not using in either of these cases? Yeah, we're not actually using the actual parameter names, right? So why are we assigning them? Why, and is add 3 a description of what this does anymore? No, it is not. So, relying on these types of, I've chosen to call these hidden mechanics because these aren't obvious to people, right? JavaScript does this, and you could find uses for it, but like, the function should always document what it does, right? And it should be obvious to anybody using the function how it behaves. Reliance on hidden mechanics is bad programming. Your program should be clear, right? It should do what it says it does. And if it doesn't, you're basically impacting maintainability and readability by yourself and other people, right? So this is a thing that you can do. Using ellipses, ... inside the argument, the function header, we specify that this parameter gets the rest of the arguments we are given, right? So this guy takes, like, you know, argument 2, 3, 4, 5, 6, etc., collects them into an array, and then you have that array inside of the code. You'll notice in this particular example, I have one parameter which is not part of the rest, right? That's what I'm initializing the sum to. And then for the rest of it, I'm looping over this array and adding that to the sum sequentially and then returning the sum. Also, notice I have changed the name of the function. It is no longer add3, it is sum. Take the sum of these numbers. Does that make sense? Shall we try that out?
Sure.
Very good. So, function, sum. Of course, there's also nothing preventing you from not even, like you're not even required to have the x parameter, right? Oh. Numlog n. There we go. Let sum equal 0. Oh, that's not what I wanted at all. For let I equal 0, I is less than args.length. I plus plus. sum plus equals args at I return sum. There we go. Sum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 10. There we go. And there you have it. And you know, I think this might not even work on an array. I think we could just put an array in this and it'd still work. Let's try it. Make you an array. Oh! Ooh. Not so much. Welcome to JavaScript. You want to know another fun one in JavaScript? Sort 1 to 100. Come on. 2, 10, 3, 7, 24. Sort is not fine, is it? What is it? Sort. Yeah, there we go. Does that look sorted to you? No. Welcome to JavaScript. So you want to know what kind of sorting it's doing? What?
Ordering it from the first digit, right?
Yeah, so it's doing lexicographic ordering over the content of the strings. It doesn't by default sort it as numbers if it's numbers. Yay! So JavaScript is a stinky, stinky language. Chaotic evil. JavaScript is a chaotic evil language. So, all right, very good. Any questions? So that's how you do function polymorphism in JavaScript. Looks like it's about time for us to have our break, actually. You guys cool for a break? Yeah? Sounds good. All right, 15 minutes. Please be ready to resume class at 11:34.
Your idea.
You said you had your assignment tomorrow.
Oh, right.
calculus. Yeah.
That's easy. I'm mainly putting all my work into the animation.
I like how I didn't see a horizontal scroll bar.
I didn't notice.
Yeah. Well, that's because you're modifying the position, the relative position, right, in terms of percentages rather than pixels. So, good job. Keep going. All right. Let us resume. I have my stimulant. Don't worry, it's caffeine. So, good. So, continuing on. We're going to talk about function references. Yes.
Oh, where do I get access to this?
I'm going to post them. I might, fix the spelling errors first. You'll find that, I run out of material around, yeah. I was going to talk about, I'm going to talk about those guys in lambda calculus, but, up to there, it's actually kind of finished, so, why are you not working? There we go. But yeah, I'll post the slides once, either in an incomplete state or a complete state. Either way, with a disclaimer, because here's the thing, right? Although this is the complete, this is I view it as a more complete version of the. This is actually important, okay, guys? Because this has implications for testing. A test. Although I consider these to be more complete in terms of their coverage of the material, I must base the test on the published existing material that's already in the course shell. So if there's something in these slides that's not mentioned in the test material, I can't test on it. That being said, I do test on the stuff I say in lecture and the content of this, but it's I have to make sure the test is fair for both sections, and the other section didn't get these slides, right? So yeah, everything that's important in the existing course materials is in here for the topics that are covered here, but this has got a bit more in it, and the more can be tested in the test. Does that make sense? Question? No? I answered your question? Okay, good. Any other questions? All right. So, I like this quote. Counting lines is probably a good idea if you want to print it out and are short on paper, but I fail to see the purpose otherwise. So basically, if your program is really, really short, you've probably compromised. Ooh, the snow is pretty. You've probably compromised readability at some point, right? It's much better to have code which is clearly understandable than code which would fit in a book better. Unless, of course, you're writing slides, in which case all bets are off. But yeah, especially given that all modern editors will enable things like code folding, so that you can scan through. You guys know what code folding is? So if you look in VS Code or IntelliJ, there's a sidebar with little hierarchy arrows. If you click on those, it'll take a function or a method and fold it up into one line, and you can view the contents from there. That's code folding. Excuse me. It helps you just read your code much easier if you use it. The other thing that's very useful is that sidebar that lets you scan through the code. very useful. Anyway. So, function references. Bit of a history lesson. Since the late 1940s, the stored program computer has dominated computational applications above the level of integrated circuits. That is to say, any computer we think of as being a computer is typically a stored program computer. What does that mean? It simply means that programs are held in the same memory system we use for data storage, right? So the program that we are executing is data, right? Held in the same place, can be modified by the same processes even. Although generally speaking, modifying your program as you're running it is a terrible, terrible idea, and if you think that's a good idea, you should feel bad, because it's a terrible idea. Functions are stored on disk, and we can refer to them the same way we refer to objects in Java, by reference. Definitely not pointers, okay guys? I know pointers is a scary word, alright? So this is definitely not pointers, okay? The difficulty comes, of course, because JavaScript is dynamically typed. So when we create a function reference, we have no type checking support. Have I mentioned TypeScript? One thing that we often do, however, in JavaScript, when we create a variable that contains a reference, either an object reference or a function reference, we declare it as constant. Why would we declare it as constant? What are constants for? Yes?
You declare something as a constant if it's something that is not going to change throughout the duration of your code.
Yes. It's something we don't want to change throughout the duration of the code. Now, an object or a function reference, like just because we've made an object reference a constant does not mean the data content of the object itself is constant, right? We can still call methods, we can still store data in the object. What's constant is the reference to the object. That can't change. And that is very useful, because if that ever became overwritten, the whole object gets sent off to garbage collection. Right? We lose the object if we lose the reference to it. Make sense? Thumbs up? Yeah? Okay, good. So, in fact, the name of a function in JavaScript is actually and really a reference to the procedure in memory. This is actually true of a bunch of languages, and it's not like, I know a lot of the slides are like, and here's why JavaScript is awful, this slide. This is actually not like, this is kind of like why programming languages in general are awful, because they pretty much all do this at one layer or another. So, let's say we declare a function, greet, return hello, all right? And then we ask for greet. Let's try that. The box means we try it. Come on. So, function, greet, return, hello. There we go. So we know what we get if we greet someone this way. What happens if we leave off the round braces? Ooh. Interesting. So, again, this might seem a little abstract, but there is a reason I am telling you all of this, all right? This is essential knowledge for working with JavaScript. JavaScript basic library functions will expect you to know how to do this, all right? There is a big O difference, not big O as in big O notation. There's a big difference between the round braces at the end of a function name and no round braces at the end of the function name. Big difference. The round braces call the function. Executes, you see hello. No round braces means we do not call the function. You may think of it as an uncalled function. A function we have not yet called, right? Another way to say this is, it is a function reference. It is a reference to a function. When we print it, we can see we are told it is a function with the little curly f, and then it gives us the content of the function. Does this make sense? Any questions? Good, I guess. Unless nobody has any questions, just because everybody's very, very confused. Is everybody very, very confused? No? Okay. Is it just that the slides are very clear? The slides are doing their job well? Fishing for compliments on the slides again? You know what? Like, I haven't taught with like slides I've made in like going on like 3.5, 4 years now. So it's almost like an old friend has come back to visit and I'm having coffee with him. That's what my feeling is with having slides again. Professor, that's really sad. Yeah, well, you know. So, when we refer to a function without including round braces, we are referring to the function by reference rather than calling it. A very, very, very common error in JavaScript is calling a function instead of referring to it. We'll see this when as we go on. We can bind a function name to other variables, or even function parameters. In this way, we can work with the function without calling it. If we wish to call the function reference at any time, you simply just slap the round braces on the end, and boom, you're now calling it. But, you know, we can bind this thing to variables. Whoa, 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 whoa. Consider the following. This is a somewhat complicated example, but here we go. This is like as simple as I can boil it down while still being kind of like a slightly interesting example. So, it is surprisingly common to give functions to other functions as method. It is surprisingly common to give functions to other functions and methods as arguments. Not as parameters, as arguments, right? The actual value that you pass is a function reference. Consider the following three functions: add, subtract, and apply, all right? In the case of add, very simple, takes x and y and adds them. Subtraction takes x and y and subtracts them. No surprises there. Apply takes f, p, and q and returns f, which is passed arguments p and q. This is a dynamic language. It's a function if you use it as a function. Right? In many other languages, we'd have to do some kind of complicated declaration here to indicate, hey fellas, this is a function pointer. Please only accept function pointers here, right? This gets particularly complicated in C. Like some of the C function declaration lines are really awful. But you know, because it's dynamic, you don't have to declare this as being a function pointer. So you can just, it is one if you use it as one, right? So, let's try that out. All right? Let's declare function add, taking x and y, and y, not xy, x comma y, thank you. Return x plus y. Boom. Subtract. Sub, there we go. Function subtract. Function apply. X, y, oh wait, no, it was F, P, Q. So, just on the subject, right? All of these parameters are, of course, local to the functions they've been declared with, right? This is not the same x and y as these guys, right? I put P and Q here just to kind of like distinguish it from these guys. I could have just said x and y again, but that might have been a little bit confusing, right? Return F, apply P and Q. There we go. Now, let's apply add 2, 10, and 20. Well, would you look at that? That works. Another very typical example of this is a map function. A map function takes a function reference and a data structure, such as an array, and it applies the function to each element of the array and returns the array with all of the values mutated by whatever the function did to them. Very, very common. In fact, before JavaScript supported the for-in loop, the way that you did a for-each loop in JavaScript is you actually had a for-each method that you called on the data structure. You had to pass that a function reference, and it was just a map function. It would apply that function to every element of the data structure. Not quite as nice or as flexible as a for each, an actual like non-method version of a for each loop, right? In the past, when I taught JavaScript, I would tell people to avoid the for each method because it just it's not doing anything you can't do with a normal for loop, and like more confusingly and requiring lambdas, right? So don't go there if you don't need to. Does that make sense? Function references? So, the same sort of substitution is happening here any other time we substitute arguments in for functions, right? When we call add 10, 5, add is substituted for f in this expression. F is now add. Now then p becomes 10 and q becomes 5 in the regular sense. Make sense? Perhaps I'm hammering it a bit too hard. The function f apply assumes f is callable and then passes the other two parameters to it. Of course, if f is not callable, you will have an actual honest-to-goodness error for once in our lives in JavaScript. You guys want to see that? You want to see, JavaScript actually produce an actual error? There you go. Uncaught type error. F is not a function. 5 is not a function. You can't 5 something, right? This isn't like the first actual error we've seen from JavaScript, is it? Might be close to it, yeah. Oh my goodness. So you can see you have to be doing some pretty arcane stuff to actually get JavaScript to actually give you an error. There you go. So, all right. So, in addition, functions are also permitted to be the return values of functions. So if a function reference can be a parameter, what prevents a function reference from being a return value? Right? So I'd like you to consider the following code example. All right? We have two functions, cake, which returns cake, and def, which returns def. We then have a function, cake or def. If math.random is greater than 0.5, return cake. Otherwise, return def. So, by the way, if you wanted to know how to generate random floats between 0 and 1 in JavaScript, that's your guy. Math.random. I'm pretty sure that that's the way to do it in Java as well. So, okay. So Java, right? Java has in the library a random class where you can generate new random numbers from a random number class thing. Don't use it. It's bad, okay? So, yes?
Sorry, can you repeat yourself?
Java has a random class. Don't use it. So in Java, it's you'll sometimes see this. Random r is equal to new random. And then you have r.next or something to get the next random number, right? Don't use it. It's using the milliseconds count on the system clock for its seed value. So any random numbers generated within the same millisecond, which is going to be a lot of them actually, right, will be the same number in using this in Java. Don't use this. Java also has access to math.random. In some form or another, it might be mathf.random, right? Use that one, because this one, similar to that one, links to the C standard library. That's right, the actual honest-to-goodness random number generator that's built into the kernel. That's the one you want, okay? Sound good? Any questions? Okay. So notice cake and def are functions. We are returning either cake or def. You may be saying to yourself, okay, why wouldn't we just return the string? And the answer is, because this is an example. So, notice here, this function, which returns a function, if we want to actually execute the return value, notice how many round braces we have going on here? This is not a syntax error. The first round brace calls the function cake or def. The second calls the return value of cake or def. Shall we execute it? Well, actually I think, okay. Okay, my laptop tells me I'm getting low on battery, so we're going to keep moving. So, you might be saying to yourself, don't worry, I'll post it, you can try it. Timing is everything, that's a cliche. Now, if I'd said that a long time ago, I'd have been original. Because the timing would have been better. So, why am I telling you about function references? Here's your introduction to the Java event system, right? As a matter of actual fact, most of what you do in Java is event-driven programming, not procedurally driven programming, right? In Java, when you execute code, it's more or less executing it autonomously because you said run this, right? In JavaScript, you set up a bunch of events and then you wait for the user of the website to activate these regions of code. So, timing events allow us to invoke functions at some point in the future and even repeatedly. Consider the following program. Function annoy, alert, poggers, set timeout, annoy, 2000 milliseconds. The set timeout function registers a timing event. The passed function, which is in this case annoy, will be executed in 2000 milliseconds, or 2 seconds. Let me show you how that works. Set timeout. Come on. Set timeout. Oh no. Yeah, I'm going to use a different one, like greet. All right. You guys ready for this? Everybody watch the screen. Enter. 1, 2. Oh, come on. Oh, it's just returning it. Ah! Here's the difference, right? If we take a look at function greet up at the top there, it's just returning the string. I confused myself. I thought it was like logging to console. Let's try it again. Racing my battery. Function hello. Oh, that one is actually console log. Okay, let's do hello. 1, 2. There it is. Right? So you know that bit on like news websites for like newspapers where it's like they let you read like 5 seconds of the article and then they pop up the thing that says you need a subscription to read any more? That's how they do that. That's the actual JavaScript function. So, yes?
I got 4 instead of 5.
Ah, that's okay. I'll explain what this number means in a little bit. So here's the thing. Here's the thing, cats and kittens. If the page loaded the article, you can read it. Just read the HTML source. There you go. That's how you get around it. Those pop-ups are only for normies who don't know how to use the JavaScript console. So, a similar function may be used to execute a function every X number of milliseconds, so repeatedly. This one is setInterval. Let's see how that looks. Oh man, battery critical. Maybe I can reduce the screen brightness. Oh man, so tense. So, set interval. Oh, that's not a correct name for anything. There we go. There you can see it's executing repeatedly. Very good. Make sense? So, of course, there may come a time when you need to cancel these events. This is where that number comes in, right? It's not surprising at all that we had different numbers, right? The return value of set timeout or set interval is an ID number for the timing event. There are two functions, clear interval and clear timeout. Clear interval, there we go, which clear the interval, right? So what you really want to do, when you call set interval, you want to save the value to a variable, use that to cancel the thing, because the ID number of the event is proportion, like it's dependent on the number of those that have been created so far on the page. So you can't hard code that value, right? You can't hard code that value. You don't know, maybe like you've imported some JavaScript to do like Google Analytics or something like that, and it's setting a few intervals itself, right? But like the number of intervals that it sets varies, right? Your script takes place after that one. It's entirely possible you get different values. But returning to our lovely, lovely thing which is still running, right? We can see that the return value for this set interval was 7. We can just see it. So we can clear it. Clear interval 7. There we go. And you can see it's no longer incrementing. Make sense? So, the important thing here, these functions take a function reference. That is the function that you are binding to the event, right? This is a very common way that event-driven systems work, right? Pardon me. Thank you. So, normally in these event-driven systems, you take whatever code you want to execute when the event fires, you make that into a function. We often give these types of functions a special name. We call them callback functions. Make sense? Any questions? Questions? All right. Well, my laptop is about to die. So, I'm gonna switch. Battery is critically low. Yes, so it is. I ran out of slides anyways.
Perfect timing, I guess.
Yeah. Yeah, you know. Sometimes things work out. Yep. So, so now, following on from that topic, we have one more thing to talk about with functions, and then we know everything we need to know about functions. All right? And that is anonymous functions. All right? So, has anybody heard of anonymous functions? Anybody ever hear of a lambda?
About what?
Lambda.
Never heard of it.
Lambda
Heard of lambda?
is a Greek letter. Anybody play Half-Life?
Nope.
No?
Never played Half-Life.
Yeah.
Never did.
They like lambdas in Half-Life because lambda is like the Greek letter that you use as the constant for Half-Life during a Half-Life calculation. You guys know what Half-Life is?
I know Half-Life.
Like what like the physics concept.
The good
Yeah.
bunch of stuff.
Yeah, it's the time that it takes for something radioactive to stop being radioactive.
Not quite. It's the time it takes for half of the radioactivity in something radioactive to dissipate. Right? So, like the thing about radioactivity is that a thing that's radioactive once will never not be radioactive, right? But the question is, at some point, the radioactivity falls below a threshold where it's like no more radioactive than your normal environment, right? So yeah, that's what half-life is. Normally, with these types of things, you have an exponential decay as time goes on, right? Half-life is the amount of time it takes for whatever it is to decay to half of its original value, right? But this is not what we mean by lambda here, all right? What we mean actually by lambda is we mean lambda in the sense of lambda calculus. Lambda calculus is a form of calculation developed by Alonzo Church, an American mathematician from the turn of a previous century, turn of the 20th century. He developed lambda calculus. He was the doctoral supervisor of a person, a famous computational scientist that you may be aware of, Alan Turing. Anybody? Alan Turing? I think I mentioned Turing in this. Yeah. So Church was Turing's doctoral supervisor. They did actually some fairly important work together. But Church was a very gifted mathematician in his own right, you know. He developed a form of calculus called lambda calculus. It was eventually shown that the lambda calculus is capable of computing everything that a Turing machine is capable of computing. It's just Turing machines ended up being more translatable to electronics, so that's why they ended up as the model for computation in electronics. But many programming languages draw a significant influence from the lambda calculus, most notably Haskell and Lisp. Basically, any language that has a lambda as part of its symbol is like, that's a lambda calculus language, right? So, lambda calculus is very simple. In its base elements, it has very few pieces, very few moving parts. You only have two operations in lambda calculus. You have function abstraction and function application. So, a typical example is this. Lambda x, x plus 3. So, what a lambda does, it takes this expression. Anywhere this symbol appears, it makes it into a function where this, the applied argument will be substituted. So, for example, if I apply 5 to this lambda, I say x is substituted for 5 in the expression x plus 3. I then perform that substitution, 5 plus 3. I then evaluate the expression, 8, and that's how it works. Yes?
Question. How's it different from like when you have f of x, like normally when you write a function of f, right? And you just put f of 5 as that kind of the same.
That was the intent behind lambda calculus, was that it's quite similar to our concept from like regular calculus of a function, right? The difference is that basically it's the difference between a function abstraction as part of the expression and being on the other side of the equal sign, right? So under normal math, you would have something like this, right? But like, we always kind of like, this is kind of like, that's just the one side of the equation. We have to put that there, you know? It means that x is the variable, but like, what does f mean, right? It means it's a function. Why? Because we decided it means it's a function, right? So under lambda calculus, you start with the expression, right? The expression has unbound variables. So if you apply a lambda, you can bind the variable. Does that make sense?
Yeah.
So that's the difference.
Okay.
Lambda calculus, as it turns out, can calculate everything. Everything. This addition operator can be written in terms of lambdas and lambda applications. You can build up all of your basic operators this way. You want to see what true and false look like in lambda calculus? This is kind of primarily for the purposes of mathematical interest. This won't be on the test. So we can define true as a lambda expression extracting x and y and yielding x. False is a lambda expression taking x and y and yielding y. So basically, true in lambda calculus is defined as a function which takes two arguments and gives you back the first. False is a function which takes two arguments and gives you back the second. I don't have time to like show you how like and or are defined, but yeah, that's like we can build everything out of just these things, right? So it's a very, very simple calculus. And basically, as compilers got more capable, like mathematicians have always loved lambda calculus, probably due to its simplicity, right? And so, you know, they've, like, even since the early days of Lisp, it's like we want a programming language, but it does lambda calculus, right? So, basically, Haskell comes out, I think in '92, something like that. It's broadly very influential in like it has a lot of influence on programming language design after it comes out. It usually takes about 10 or 15 years for a language to really have influence on other languages. But anybody hear of Rust? Any Rustations in the crowd? Yeah?
I've heard of it.
Yeah.
Talked about it in the last chapter.
Yeah, Rust is a very difficult language to program in. Probably coming close to being as hard as C++, which is like one of the hardest languages to program in, which is why I recommend it to everybody. Rust's type system draws a lot of explicit influence from Haskell. So you have to understand functional programming to be able to program Rust, which means that Rust is actually a rare skill, which means everybody should learn it. Because, you know, basically you want to compete in a job market with fewer people in it, and if you are good at a difficult language, that excludes a bunch of people who are actually that good at programming, right? Okay. But Haskell and lambda calculus have not only been influential on Rust. A number of years ago, every language started introducing lambdas, right? A syntax for lambdas is now something that most programming languages support. JavaScript being no exception. So basically, what a lambda is a function without a name that you declare in line. Right? So, we can get there in JavaScript as follows. Consider the following function. Function hello. Hooray! We call it. Very good. So far, so good. We've made a hello world function. Whoop-de-doo. Watch this. Can anyone spot the difference? What's the difference? Ha! It's a trick question. There's actually no difference. There's some syntactic difference, but semantically, these two are doing the precise same thing. In this case, we declare a function hello. We provide the name here. We're using regular function declaration syntax. Here, we are declaring a constant goodbye. To that, we are assigning this function. We are binding a function to a variable. Oh, but here we are binding a function to a variable. See the point I'm making? If this is correct syntax, which it is, then this thing exists without that part. That's still valid syntax. Right? Which means, boys and girls, cats and kittens, you can actually define these things in line. If you try to just create it on its own, it'll give you a syntax error. But what did I do here? All I did was call it, and it works. You will find a lot of the time, like this is not even abstract, right? This isn't like academic information. This is the way that you will bind functions to events a lot of the time, right? When you write an event, it's very often the case that that function, like the callback function, will be unique to the event it's bound to, right? Make sense? In those cases, it doesn't really make sense to declare the function separately. You can declare the function right there inside of the other function. And that's often done using this. This, my friends, is an anonymous function. Why is it anonymous? It doesn't have a name. So, does that make sense? Okay, variant number 1. Let me show you variant number 2. Variant number 2, in JavaScript, they call them arrow functions, but they are lambdas. It's just a lambda. They've called it something else, right? So,
Sir, I'm having problems. Oh, wait. No, yeah, I'm having problems.
okay, give me 2 seconds. Lambda. Right? So, you'll notice we have arrow, the arrow operator. This is a list of arguments, right? Normally you see like 0 or 1, but this is a list of arguments. You can have as many as you want here, right? Arrow, x plus 3, apply 4, answer is 7. Exactly that thing that I was doing on the board, right? Couple of key differences. Notice the lack of curly braces. Now you can't actually include curly braces here, but in the anonymous function, the curly braces are mandatory. In the lambda, they're optional. Make sense? Oh, come on. Every time. Yz times y plus z. 1, 2, 3. Now let me see. We're having a syntax error.
I have a few. See the problem
You're missing a round brace right there.
after the hospital.
After the curly brace.
Here.
Oh, I see that.
So, arrow notation. Again, it's a lambda. It's just a lambda. It takes an expression here. It says, I am extracting x, y, and z as arguments. You can pass those in, and it performs the calculation. Any questions? This we will see less frequently than this one, but you'll still see it reasonably frequently. So basically, how do these get used in practical terms? Anywhere a function reference is required, but you don't want to separately define the function, you can put an anonymous function in that slot. It tends to make JavaScript look pretty messy. But this is practical JavaScript code. This is stuff that you will see. Set interval. Right? Every 5 seconds we get an alert box that says annoyances. And guess what? These things actually stack. I don't recommend this. This is the worst thing to do ever. I'm going to have to reload the page to clear it. Unless you can type clear interval 33 in less than 5 seconds. Yeah, normally I might be able to, but under present circumstances, my typing, I've been typing with sufficient inaccuracy today that probably would be only amusing to everybody in the room. I would not be amused. Okay. Make sense? Any questions? Again, it makes the code uglier, but it is often done. In fact, a lot of the time, an event ends up looking like fancy curly braces for the function inside of it. Make sense? Okay, good. So, see? Ha! I did it. There we go. So, We still have a little bit of time left, and I'd like to at least get us started on DOM manipulation. However, I also really have to use the washroom, so I think I'm going to go do that. 2-minute break. There we go. All right. So basically, we have turned a corner in the course now. We now have discussed JavaScript, the language. There are going to be more things we talk about, obviously, but we now have enough JavaScript under our belts to actually do something useful. We are now pivoting to learning how to do stuff that's useful. All right? So, it's all well and good to know about, functions and expressions and all of this stuff, but fundamentally, what is the purpose of JavaScript? Yes? To make your pages nicer. That's right. So, more dynamic. Right? We're trying to make the pages do stuff. Right? Now, this means, because everybody in the room is a programmer, you should always be thinking in terms of input and output. Right? What is our input? User actions. What is our output? The appearance of the page. Right? So, we need to learn how to modify the appearance of a web page and how to respond to user actions. Right? Basics. This is generally lumped under the title DOM manipulation. DOM, document object model. Remember the document object model from like the first class or the second class or something, right? We've had a bit of Java since then. We've talked about objects. So we should have a firmer grasp on what an object is and what it means for the document to be modeled as one. Right? So, basically, there is a document keyword which is the web page expressed as an object. So, for example, let's take a look at Wikipedia. Right? Wikipedia en anglais. Ooh, this looks like an article of the day. Friedrich Wilhelm Freyer von Seydlitz, Prussian officer, lieutenant general. Okay, a cavalry general. Sounds good. So, what is document? Well, it's actually quite handy. The JavaScript console will highlight in blue the region of the web page that you've got targeted. So document is all of it. There we go. But of course, the document has child objects. How do you access child objects? Children. Let's choose child 0, which is a thing. containing head and body. Head is the second child, so we can say dot children at 1. Or that'll give us the body. There we go. Dot children let's say 6 is a script. No, let's go 9. No, 11. Undefined. 10. Let's just see what they are. Here we go. So you can kind of see what we're doing here, right? We're traveling down through the object hierarchy to find particular elements of the page. But of course, we're running into difficulty. Say I wanted to, modify that link in JavaScript, right? Are you going to navigate this whole thing every time, starting from the top down to the bottom, using children? Probably not. It's not practical. Not to mention, the web content is going to be dynamic anyway. So if you write your JavaScript code, assuming that there's a particular path to the element that you want through the document, one change to that website and your code is junk, right? Breaks all your references. So, the way that we get to elements through the document object model, we use a search method. Now, there's an old, crusty, boomer way of doing this, and there is a hip, young, what is it, fire? Fire is the adjective that's used. The fire way of doing this is to use, oh, I just ruined it, didn't I? Yeah, you're going to have to find a new word now. Document.query selector. So query selector is different from get element by ID, which is likely what you've seen before if you've seen anything. If you studied a little bit of JavaScript in high school or something like that, the get element by ID is likely the one you learned. Query selector allows you to use general CSS queries, right? So you can select any amount, any number of things, any particular thing by ID, by class, whatever you like. You can even use fancy pseudo selectors, right? So let's get a link. Jump to content is the content of that link. You also have a variant called query selector all, which gives you every link on the page. Right? So if you say query selector all A, give me the 10th link, aha, you can see that box doesn't seem to line up with the thing, but recent changes, let's try 20. What's the 20th link? You're encouraged to log in, however, it's not mandatory. Okay. 30th? There are a lot of anchor tags here. Character? Yeah, anyway. You can see you can access whichever of the links you want. They store them all in an array and you can get them. If you happen to know the ID of any of these, you can also select by ID. Because this is a page I wrote, I don't know what any of the IDs are. I'd have to look through the HTML source, but that's how you get references to things. You need references to things in order to modify them. Right? Make sense? Okay. I think that's about as much damage as we can do for one day. Please like, subscribe, leave a comment, and and we'll see you in the next one. Thank you very much, everybody.